In order to understand algebraic expressions, we need to look at the individual pieces that each algebraic expression is made of. These pieces that form algebraic expressions fall into two categories: variables and constants. A variable is a symbol that represents a value that's unknown or not constant. They're often represented by letters such as x or y. Variables can be represented by themselves or represented in sets. That's when we see a coefficient. So x, or 3 sets of x, 3x. A constant is a known and well-defined value. A constant is something that we could count out. I could count out 12 pieces of pizza. I could count out 6 pieces of pizza. Simply put, a constant is just a number. Whether it's a decimal, a positive, a negative, a whole number, a fraction, a constant is a number. On your own, draw a box around the sets of variables. Draw a circle around the constants. For example, 3 I would circle because it's a constant. I could count out 3 things. X is a variable. I don't know what x represents, but it represents a value, an unknown, a non-constant value. 32 is a known constant. Negative 43b, that's negative 43 sets of b. b is an unknown and not constant variable. Circle or box each of the other terms to find which are sets of constants, which are sets of variables. Coefficients are the values that we find in front of multiple sets of variables. A coefficient represents multiplication, but there's no net multiplication symbol involved. Think of it this way: if you put 2 rabbits next to each other, they multiply. If you put a value and a variable next to each other, they're also multiplying. So if we look at 2x, 2 is my coefficient. I'm multiplying 2 times x. In the case of a times b times c, we don't have a direct coefficient because there's no number, but a, b, c can all be written next to each other. On your own, try to write out negative 4xyz as multiplication. Negative 4 in this case is our coefficient. The value in front of a variable is the coefficient. It tells you how many sets of that variable you're dealing with. This is the value that's being multiplied by the variable. In the examples below, try circling the coefficient in each term. 3 is the coefficient for 3y. Negative 2 is the coefficient for negative 2x. Circle the coefficient for all of the other terms. Algebraic expressions are composed of the individual pieces, constants, and variables that we've just looked at. An algebraic expression is a mathematical combination of constants and variables combined using the major operations. So a couple examples we have here are 3x minus 5. 3x is a set of variables. 3 is my coefficient, x my variable. Minus 5 is my constant, my known value. So I see multiplication 3 times x, subtraction minus 5. We have a couple other examples here, 6y minus 8x plus 2. These algebraic expressions are made up of terms. A term is a constant, a variable, or a set of variables made with multiplication. So that's a variable with a coefficient in front of it. They're combined using addition or subtraction to make algebraic expressions. So below we have the same examples we just looked at. Now we have their individual terms circled. 3x is 3 sets of x. That's one single term. 5 is a constant. It's one term. They're being subtracted. 6y and 8x are both sets of variables, different variables, but sets of variables. I know they're sets of because there's a coefficient. 6y is a coefficient of 6. 8x technically has a coefficient of negative 8 if you're looking at the subtraction symbol in front of it. 2 is another term. It's a constant by itself. I see that these individual terms are broken up by addition or subtraction. 3x squared is a set of x squared. So 3 sets. 3 is my coefficient, so it's 3 times x squared. Plus x. X is another set of variables. Now this is not the same as x squared. These are different terms. 2 is a constant, 2 is another term. They are being separated by addition and subtraction. When we look at algebraic expressions, we can name them based on the number of terms. These are what we call polynomials. If we have just one term, in this case x, There's one term, we call it a monomial. If we have x plus 3y, that's two terms. X is one variable, 3y is three sets of y. It's another variable. There's two terms there. Just like a bicycle has two wheels, a binomial has two terms. If we go up to three terms, we have x plus 3y plus z, three terms. Just like a tricycle has three wheels, we call it a trinomial. Once you start looking at expressions as being made up of individual terms, you can start seeing trends in those terms. We call these terms that can be categorized together like terms. Like terms are terms that have the exact same variable and exponent. The coefficients in these terms do not need to be the same. So for example, if I had 3x and 2x, x is the same variable. I have three sets of x and two sets of x. The coefficients are not the same, but they're the same exact term, or they're like terms. Constants are always considered like terms. So anything that is not a set of variables, anything that, again, is simply a number, they are always like terms. Let's look at how we categorize these like terms. I have an underlining method, a shading method. Find the visual cue that helps you. So I see 4x squared. So I'm going to look at my other terms. I see negative 2y, positive 3x, positive 2, minus or negative 4y, positive 7, positive z, and positive x squared. Well, I see four sets of x squared and one set of x squared at the end. So that's x squared and x squared. They're like terms. They have the same variable and the same exponent. The coefficient doesn't have to be the same. I'm going to look at my next term, negative 2y. I'm going to see if there's any other terms that are the same. So I'm looking for any other sets of y. I see 3x, nope. I see 2, nope. I see negative 4y. So I'm going to double underline both of those. 7 and z are, again, different. They're unlike terms. So I need all sets of y. Now I see that there's 2x squareds, 2 y's. Those are going to be combined eventually. Then I look at my next term, 3x. I'm going to triple underline that and see if I have any other x's. I see a term that's positive 2, a term that's positive 7, a term that's positive z. There are no other x's. 3x is already simplified down. I'm looking at my next term. It's a constant. So all other constants are going to get 4 underlines. So 2 and 7 are my only two constants. And then z is all by itself. So z, the sets of z's, that particular term is already simplified. Categorizing your like terms is the first step to combining like terms and simplifying your algebraic expression. You can use the underlining method above. You can use different shapes. So I see that I have 4x squared and x squared. I'm going to circle them both. Negative 2y and negative 4y, those are like terms, both sets of y, and put a square around them. 3x, I'm going to put a square on its side, a little diamond. 2 and positive 7 are both constants. They're like terms, and put triangles around them. I'm going to put an oval around z. In both cases, I see which variables I'll need to be simplifying or combining together, or which like terms are going to be simplified and combined. Not only does this help you organize which terms are going to be combined, but the number of categories equals the number of terms in your final answer. So in both examples, I see that I have one group that's single underline, one group that's double underline, one group, etc., all the way up to 5 underlines. I have 5 categories. I have 5 different numbers of underlines. I have 5 different shapes. My final answer, unless something cancels out, if I have negative 5 plus positive 5 and they cancel out, I should have 5 terms in my final answer. Notice when I underline or circle or square, whatever shape, I include the sign when I categorize. That helps you when you go on to add and subtract, when you actually combine these like terms. Before we get into the details of how to combine like terms, let's look at why like terms can combine. Multiplication can be written as repeated addition. So in the case of 6x plus 2x, I have 6 times x plus 2 times x. 6 and 2 are coefficients. Remember, you put a value next to a variable, it's like putting 2 rabbits next to each other. They multiply. So I can rewrite 6 times x as 6 x's being added together. X plus x plus x plus x plus x plus x. I can write 2 times x as repeated addition, x plus x. If I add them all together, that's a total of 1, 2, 3, 4, 5, 6, 7, 8 sets of x. Notice if I take 6 plus 2, the coefficients, 6 plus 2 makes 8. Likewise, if I take 4x plus 3x, that's 4 times x plus 3 times x. 4 and 3 are my coefficients. I can write 4 times x as x plus x plus x plus x. I can write 3 times x as repeated addition, x plus x plus x. That's a total of 7 x's. So 4 plus 3 makes 7. Little think, pair, share. Write down your answer to this question. Is there a connection between the coefficients and the total number of x's or variables? Can you complete this statement? When you combine like terms, just add their what? What relationship did we just notice? If you have a strong understanding of terms and how to categorize like terms and unlike terms, combining like terms becomes very simple. Step 1, organize all terms in the algebraic expression using a categorization symbol. So we've looked at using shapes, we've underlined, sometimes people will pull out colored pencils and color code them. Whatever you need to do to show the terms that are like. So in this case, I see 8x. I'm going to circle all of my sets of x. I see 8x, 5 is a constant, negative 3x, there's a set of x, minus 2, that's a constant. So I'm going to look at my next term, plus 5 or positive 5. I'm going to put a square around that, square around all the other constants. Those are all my terms. I see that I have two different categories. I have circles, I have squares, so I have constants, and then I have sets of x. That means my final answer should have two terms, unless something cancels out. In order to combine these terms, we need to treat each term as either positive or negative. It'll help when we get to adding them. So treat each term as being positive or negative. I have positive 8x, positive 5, negative 3x, negative 2. That's why we circle, square, underline, categorize, including that negative sign or positive sign. Whether it's being written as a plus or minus, it's the same constant or concept. Minus is the same as negative, plus is the same as positive. Next, we're going to add all sets of like variables. Just add the coefficients. This is the relationship we observed a little bit ago. So I have 8x and I have negative 3x. 8 plus negative 3, so let's look at the coefficients. 8 plus negative 3 gives me positive 5x. So those two terms simplify down to 5x. If there were other variables in this algebraic expression, we would then add them up separately. Usually, you would see it commonly written where the variables follow in alphabetical order: x, y, z, a, b, c. Last but not least, add all sets of constants. I see positive 5 and negative 2, so I'm going to add those together to get positive 3. My algebraic expression is now complete. I said I'd end up with two terms. I ended up with two terms. I combined my x's. I combined my constants. Looking at this answer, could the answer be 8x? Could the answer be 8? Why or why not? Well, if we look at this is probably the most common error. A lot of students are so used to dealing with answers that simplify down to one single number answer. So they'll take 5x plus 3. Well, 5x is a set of x. I don't know what x is. I could hold 5 unknowns. It could be 5 single dollar bills, 5 $10 bills, 5 $100 bills. Whereas with 3, it's a constant. I know what $3 bills look like. I can hold that in my hand. They cannot combine because one's known, one's unknown. It's like oil and water. They don't mix. Let's try a couple problems together. I have t plus 11 minus u minus 14u plus 13t. So I'm going to look for all of my like terms. I'm going to categorize them. So I see t, and I see 11, negative u, negative 14u, and 13t. Well, I only see one other set of t, so I'm going to put a single underline under both of them. I see a constant, positive 11. I'm going to double underline it. I'm going to double underline any other constants. There are none. I see only sets of u left, so negative u and negative 14u. So the constants are already simplified. I see a negative u, so I'm going to combine that with all other sets of u, in this case negative 14u. This way I know which terms go together. T and 13t are going to be combined. 11 is going to be by itself. Negative u and negative 14u are going to be combined. So I'll start with the variables. I'll go in alphabetical order. 13t plus positive 1t. Remember, that's those invisible ones of math. Just because it's a variable by itself doesn't mean it does not have a coefficient. Anything times 1 is just that, anything. So t times 1 is still t. So I take t plus 13t, and I need to get 14t. That's the first term. Next term I'm going to combine my u's. Negative u is in the same boat. It's negative 1u. So that's negative 1 plus negative 14 to get negative 15u. The constant's already by itself, so I'm going to take my first term, 14t, minus 15u, plus positive 11. There's nothing that needs to be combined with the constant. It's in its own category. There's only one term that's double underlined. That's why the categorization system really helps. On your own, try these two questions. Then take a look at the helpful hint at the bottom. We've discussed this as we've gone through the problems, but remember, to organize your algebraic expressions so the variable appears first, followed by the constant, variables should be listed in alphabetical order from biggest exponent to smallest. So that means alphabetical order X, Y, Z, A, B, C. If you start seeing exponents, x cubed, then x squared, then just x.